So today we're going to be using your calculator because we're going to be computing for the mean and the standard deviation of an ungrouped data. So last week we've learned the empirical rule, and in the empirical rule, we use the normal distribution or normal approximation, which is given by mean and standard deviation. So those are the two Greek symbols that we used for the mean and for the standard deviation of a group data set. Now, the mean and the standard deviation is important in a normal curve because if you have a normal curve, the mean is always the peak or the center of your bell-shaped curve, and the standard deviation, it's the dispersion or how far away your data set on the average from your mean, above or below the mean. So anything above the mean is going to have a positive z-score, and anything that has below the mean is going to be a negative or below average value. So for today, we're going to be calculating for the mean and the standard deviation. And the reason why we need our calculator is because the formula for finding the standard deviation is not as easy as calculating for the mean. For the mean, it's easy and very simple because the mean is just the average of our distribution. Let's have our first example. Number of siblings. So let's say I'm interested to figure out the value of the mean and the standard deviation of the number of siblings in our class. So in the chat box, can you please type in the number of siblings you have? If you're an only child, 0. If you have 2 or more siblings, obviously you're going to say or write down 2. Are you going to include half siblings? No, let's not include half siblings. Your siblings from the same set of parents. Type it in. Ike has 2, Jenna has 2, James has 3, Yesenia 2 siblings, Anna 2 siblings, owner 2 siblings, whoever that owner is, Diane 4, Jose 6, Maureen 2, Sarah is here 7. Oh my goodness. Jose 6. All right. Since this is our first calculation for the mean and standard deviation, I'm just going to choose the first 5 entries. First 5. First 5. 2, 2, 3, 2, 2. All right. First 5 of you is included in our example for today. And again, I want to start with small because the formula for the standard deviation can be a little bit confusing. So let's just start small. So the first thing that we need to do is to compute for the mean. And to compute for the mean, I'm going to introduce a Greek letter. It's summation of x sub I all over n. That is the mathematical formula for the mean or the average. And computing for the mean and the average, you know that it's going to be easy if you have a calculator. So get your calculator and compute. Now, in your calculator, this symbol, this Greek letter symbol, is the sigma notation. I think we've used this before, right? Type it in. Yeah, I think we did. So this sigma or symbol of Greek letter, it's called to add them all up. And x sub I, it's this values right here. These are your x's, and we call it as x sub i's. So that means we're going to add them up. So we'll have 2 plus 2 plus 3 plus 2 plus 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then we're going to divide it by n, and the n is our sample size. So the letter n is the sample size, and the sample size is the number of data sets we have, and we have 5 of them. So all we need to do is to add them up. 2 plus 2 plus 3 plus 2 plus 2, 11. 11.5, or we need to change this into decimal, because that's what we're going to be using, divided by 2, 5.5. So the average of our 5 students and their number of, huh? Is that right? Because in the calculator, I divided by 2. It's supposed to be by 5. All right, 11 divided by 5, 2.2. So this is wrong. 2.2. That is the average. So the average number of siblings of our 5 students is 2.2, which is, let's say 3, because there's no 0.2 person. So on the average, those 5 students have 3 siblings. But we need to know its dispersion, and we're going to compute for it. And for the standard deviation, so type this in. Is finding the mean difficult? Yes or no? I want to know your answer. Is it difficult to compute for the mean? Yes or no? Type it in. So far, no, 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 no. Leilani says yes. Probably she's doing her computation in her head. Obviously, it's going to be difficult. So use your calculator if you don't want to make this too complicated to you, because for today, we're going to learn how to use technology in calculating for a mathematical procedure. So standard deviation is given by this symbol, and the standard deviation, the formula is going to be the summation. So we're going to be adding again, and it's going to be the summation of x sub I minus the mean, and then you square it. After you square it, you're going to divide it by the sample size. And after dividing it with the sample size, we are going to take its square root. So that is the value of the standard deviation. So that is why we need to use the calculator, because the formula is big and we're using summation, and we know that we're going to be doing a lot of calculation today. Now, before we move on and using the formula, first, let's make sure that you know how to use your square root function in your calculator. Can you please give me the value of the square root of 9? What is the square root of 9? The square root of 9 without using the calculator, we know is equal to, type it in, it's 3. So it's easy if we're taking the square root of a perfect square. And perfect squares are 1, 9, 16, 25, 64, 144, and so on. So square root of those numbers are easy to find because they're perfect squares, and their answers were going to be integer or a whole number. But what is the square root of 2? I want you to use the calculator, and in my calculator, the square root of 2 is second function square root of 2. I'm getting 1.414, so this is 1.42. 1.41, because we need to round it up to the nearest hundredths or 2 decimal places. Now, can you use your calculator and the square root? Because you're not going to be able to produce the formula if you don't even know how to find or use the square root function in your calculator. So learn how to use your calculator first before we move on to our computation. Are you good?
Yes, you can continue. I brought it out.
Okay, go figure out how to get 1.41 in your calculator, okay? In Google.
Okay, I will.
All right, now, since the formula is too big, we're going to make it a little bit more systematic, because in mathematics, we can just use this like how we computed it for the mean. but I'm going to use a different technique, and this technique is the spreadsheet technique. If you know Excel, that's basically what we're going to be doing. We're going to do Excel on paper. So that's one technique that we use, or students in statistics were using probably in 1985, when there's no calculator or no computers yet. So they use this. They use this technique to be able to produce the standard deviation more accurately and more systematically. So this is how we're going to do it. We're going to use table. All right. I hope that you can draw a straight line. That's your first challenge for today. So if you can draw a straight line, we'll be able to create our table without a straight edge. So the first thing that we need to do is to write down our exabytes. And our exabytes, they are the given values. And the given values we're using are the number of siblings. 2, 2, 3, 2, 2. All right. So that's our exabytes. And let's write down our mean right here, which is 2.2. Let's just write it there so that we can see it and we can access it easily. And now the next thing that we're going to do is for our second column to appear. And for our second column, all we need to do is to write x sub I minus mu. X sub I minus mu. And that is our second column. So what does that mean? So x sub I minus mu is basically, this is your x sub I, and you're going to subtract it with your mean. And your mean is 2.2. So for your second column, we're going to write 2 minus 2.2 equals, and then we'll use our calculator. 2 minus 2.2 equals negative 0.2. Negative 0.2. Did you get that? 2 minus 2.2 is negative 0.2. Then you're going to use the same formula for each one of these, all right? All right. So that is our second column. We're basically just producing this part of our formula for the standard deviation, and that is column 2. Now for the next column, column 3, we're going to use the calculator again. We're going to produce this. X minus mu squared. And how are we going to produce x minus mu squared? Easy. Because we know that x minus mu is this. This is our x minus mu. All we need to do is we're going to square it. So we're just going to square it using the calculator again. So get your calculator and we're going to square each one of these. So we'll have negative 2 square. Do you know how to find your square in your calculator? Negative 0.2 square. Wrong. Negative 0.2 square. All right. So I need to put it in a parenthesis, because if it's not in the parentheses, it's going to give me the wrong value, because we know that negative times negative is going to be positive. So the reason why you have the square value in your formula is to make sure that all your values here will be positive. So negative 0.2 squared is positive 0.04. Is that what you got?
Professor, what are we hitting?
Yes.
Are we hitting the square root button on the calculator?
You're hitting the square button.
Just where it says square root?
X squared. It says X squared in your calculator.
Okay.
In some calculator, it's X squared. Some is n to the 2. Some is just a square. But if you don't know how to use your calculator and you don't know how to find or locate X squared, this is another technique. Do negative 0.2 times negative 0.2. And it's going to give you 0.04. So can you please complete the last column? So we have 0.04 here. So the next one would be, it's going to be the same because it's just going to be negative 0.2 again. So this part of the formula. And how we're going to use that formula? It means summation of the third column. So we're going to add the third column up. So use your calculator and add them all up. 0.04 plus 0.04 plus 0.64 plus 0.04 plus 0.04. Waiting for the standard deviation. And the standard deviation, it's the summation of x minus mu squared all over n, and then they take the square root. Now, how are we going to translate it to the work that we are doing? All of these that you're seeing in your numerator, the big formula with the Greek letter, that's 0.8. Divided by n. And what is n in this
5.
problem?
5.
5.
That is correct. That is 5. Now, can you please use your calculator and compute for this value? 0.8 divided by 5. And 0.8 divided by 5, I got 0.16. Is that what you got?
No.
Do it again. 0.8
Yes.
divided by 5.
16.
Did you get 16?
Yes.
I mean,
Yes.
0.16, I'm sorry.
0.16, yes.
Equal to 0.16, but that's not the answer yet. Because what is missing? What is the last step in our problem?
Square root.
Yes. You need to take the square root of it. So to take the square root of a number, that's why I want you to use your calculator and make sure you know how to use it right. We're going to take the square root of 0.16, which is 0.4. .4 or 0.40, and that is our standard deviation. So the standard deviation is 0.4. And again, just like what I mentioned a while ago, computing for the standard deviation, it's not as easy as computing for the mean, because computing for the mean is pretty straightforward. You add them all up divided by the number of sample size. But for the standard deviation, it takes a little while to complete. And just like any other math problems, it's always difficult to work on problems like this at the beginning. So let's have more examples. So we have, so our answer is that the mean, I'm all over the place. The mean is equal to 2.2 and the standard deviation is equal to 0.4. That's the value that we're looking for. And for today, that's all we're going to be doing, computing for the mean and the standard deviation of a group data. And the number of dogs in this household is given by, I mean, they took a survey of 9 people or 9 households, and there's 9.
Your paper is too high up.
Oh.
Yeah. There you
9 to, can you please tell me what the value of n in our problem?
6.
6. Because there's 1, 2, 3, 4, 5, 6 data sets or 6 survey in this problem. Now, let's compute for the mean. Can you please compute for the mean on your own? 7 divided by 6. Yes, 6.5. All right, now, I'm assuming there's no problem with computing for the mean. The only challenge is computing for the standard deviation. So now that we're working on the standard deviation, we're going to use the table again. So draw your table. The first column is your exabytes. And the x sub i's will be your number of dogs. 9 dogs in a household, 2 dogs, 5, 4, 12, and 7 dogs. All right, so 6 households have those number of dogs, and we're going to compute for the standard deviation. And the standard deviation, the formula is summation of x sub I minus mu squared divided by n, and then you take the square root of it. All right, so we're going to produce the second column, and the second column is x sub I minus mu, and mu is 6.5. So that means x is 9 minus 6.5. Now just use your calculator and produce those values. You don't need to rewrite every single one of them. That's why we have the calculator. All right, let's move on to the third column. And the third column is x minus mu squared. And how are we going to produce x minus mu squared? We're just going to multiply these twice. So we know all of our answers will be positive because every time you square a number, it's going to be a positive number. Okay, 2.5 squared. What is 2.5 squared? I got 65.5, and the example in my computer says 65.5. Are we finished? Because this is our numerator. That is our numerator. So now we have the square root of 65.5 divided by, what is n?
6.
Yes. Okay. Can you please use your calculator to give me the standard deviation? I'll do it in my calculator. 65.5 divided by 6 is equal to 10.9166667, and then I'm going to take the square root of it. Second function in my calculator, 3.3. And that is the standard deviation. So that is how you calculate your standard deviation. Now let's use your data set again. I'm going to do a survey. What can I ask you guys? Any suggestion that you want me to collect?
Who's been staying at home and who hasn't? Just kidding.
Shoe size.
Shoe size? But shoe size is different from girls and boys. All right, let's do shoe size. Okay, can you please type in your shoe size? Diane, your shoe size is 1? Huh? Is it possible to have a shoe size of 1? And if your shoe size is 9.5, like Candice, we'll round it up to 10 so that it's not too much to work with. 10. Let's stop at Jose. We collected 8 of your shoe size, and we collected 1, 6, 10, 10, 7, 7, 10, and 8. Can you please compute for the mean? What did you compute? What did you get?
7.3.
Can you please type it in? Deborah is 59. Now, Deborah and Jose, you forgot to divide by 8. You need to divide it by, we are seeing 7.37. So let's do, okay. So the mean is 7.4. So our average shoe size, it's like a tongue twister. Average shoe size is going to be 7.4. Now let's compute for the standard deviation. So let's write down the crazy formula. And we're going to be producing the second column. And the second column is x sub I minus the mean. Okay, so we'll start small and then we'll go up. So we will use the calculator. Will be 1 minus that's the value I got. Can you please check if you have the same answer?
Why'd you put 3.6 for the 10?
2.6. Is it 2.6?
Yeah.
See, I told you, I'm gonna make mistake.
3.6.
Apparently it's wrong. Because 10
I was too.
minus 7.4 is 2.6. Is there anything else that I need to correct? Okay. Can you please check my work? Is it the same as yours?
Yes. Yay.
Good. Now for the next step, you're going to add them all up because that's the numerator. So can you please add this all up? So I guess everyone has the same value. So I'm confident that my summation is correct. So now can you please compute for the standard deviation because you have all the ingredients that you need to use the formula for the standard deviation. So can you please give me this? 2.83. Or 2.8.
Oh, I didn't square root. That's why.
Make sure to square root it because that's part of the calculation. Because if you don't square root it, it's going to be a variance, not the standard deviation. So our mean and the standard deviation is 2.83. So boom, boom. This is how we compute for the mean and the standard deviation of ungrouped data set. And this is going to be your homework for this week. So what you need to understand about calculation or computing for math problems like this is that one, you need to be patient, and two, you need to be accurate with all the steps you're doing in your calculation because the calculator, it's only useful if you're using it right and if you are giving the right information to your calculator. If you give your calculator the wrong information or the wrong value, it will not help you no matter how powerful your calculator is. You can be using a powerful calculator like this or just your cell phone. It doesn't matter if you don't know how to use it. So that's your goal for this week, making sure that you are using and understanding the crazy formula of the standard deviation and calculating for all of these. Now, when do we use the mean and the standard deviation? We use it just like how we used it last week. So the standard deviation is extremely important in statistics because it measures how wide or narrow your data set is to each other. And in statistics, the smaller your standard deviation, that means you have lower variability, or in a little bit more term that is understandable, consistency. So if you have a smaller standard deviation, that means your sample is more consistent. Now, look at our sample right here. Diane has 1 as her shoe size. We have a bunch of 10s. We have a bunch of 7s. Our standard deviation is 2.83, which is a little bit a wide gap because we have an outlier. We have a 1 right here. So that's why their differences is about 3 shoe size differences among the 8 people that we collected. But had we have a more consistent data set, this would have been smaller. Just like, look at this. Look at this sample that we have. This is the sample for our number of siblings. In the number of siblings we collected a while ago, the number of siblings I collected is pretty close. 2, 2, 3, 2, and 2. That's why when we computed for the standard deviation is really small, 0.4, not even 1. So that means if you have a more consistent data set, you will have a smaller standard deviation. And that is why statistics and numbers are important, because in statistics, it's not just the how. The how is just part of why you're doing the mathematical work. It is the why that you should be able to be understanding. And in most cases, for students who have never taken any stats class, they can understand mean or average easily because we use the mean and the average pretty much always, like average height, average rate, average annual income. But standard deviation, it's a little bit abstract to most students because they're using it rarely. But if you know what standard deviation is, just like what we have computed and calculated, we'll be able to have a better understanding of a data set, if it's consistent or our data set is consistent or inconsistent. So smaller standard deviation is a good indication that your population or your sample is consistent. Or in statistics, we call it less variable. So the lower the variability is, the better in statistics. Now, you need one more example. So we're good? Can I
We're good.
can I
Yes.
go
We
now?
can.
Can I eat now?
We're good. Go eat.
Good. Go
Yeah.
eat.
Hey, make sure to always follow and organize work because that is the key in answering problems like this. Be organized. Okay?
Okay.
All right, guys. It's
Sure.
been great seeing you guys
Sure.
again. I'm excited to see you next week, and I'm looking forward to receiving your homework.